welcome, Professor Miaole Hou. Just by way of introduction, Professor Hou is currently the Vice Director of Human Resources in BUCEA and the leader of the Institute of Digital Architecture Heritage. She is a member of the Beijing Society for Surveying, Mapping and Geoinformation, a member of CIPA-ICOMOS-ISPRS, and a reviewer for the NSFC, Journal of Wuhan, University of Acta, Geodaetica et Cartographica, Sinica. And Dr. Hou was selected by the Beijing New Science and Technology Talents Training Program in 2008 as Beijing Talented Person Training Program in 2010 and the Beijing Young Top-Notch Talent Training in Program 2012. Her research interest lies in 3D information extraction and virtual restoration of cultural relics. So, Professor Hou, welcome, and thank you for joining us at such an early hour in Beijing.
Okay, thanks for the introduction, and thanks for inviting me to have the opportunity to share some related works of my research team. Today, I'm just going to talk about the spatial intelligence and virtual restoration of Grotto status, just based on the 3D cloud point. And just as introduction, my name is Miaole Hou, and just work for the Beijing University of Civil Engineering and Architecture. And firstly, I will introduce some basic concepts. Actually, the definition of Grotto status, Grotto status just refer to the stone contour relics that are artificially dug on the giant rock cliffs to highlight the traditional culture and art, the career of human civilization, and the witness of the integration of Chinese and Western cultures that have extremely rich historic, artistic, and scientific values. There are a lot of Grotto status in China, maybe more than 5,000 and so on. Recently, maybe there are a lot of some works just based on the just status digitalization. The result of the digitalization is just the digital heritage. Maybe it's just consists of some unique resources of human knowledge and expression. It embraces culture, educational, scientific, and administration resources, as well as some technique, legal, medical, and other kinds of information created digitally or converted into digital form from existing, maybe some heritage. Recently, just the digital heritage is very popular. We just do some research based on these digital resources. And digital heritage may be just the research object just for my research team. And firstly, we just analyze some characters of the digital heritage of the Grotto statues. Maybe it has three main characters just related to the spatial and some time. Firstly, maybe just the multi-source character, just because maybe this data comes from the remote sensing image and LiDAR, maybe photogrammetry and 3D laser scanning, some images and some other sensor monitoring, just because there are a lot of resource we can get the digital heritage. And another important character just is the multi-scale caricature, just because if we want to know the heritage, maybe we need to know the environment, so maybe the macro scale. We also need the detail of the heritage itself, maybe just a Mexico pig, and another we need to know the detail of the heritage. Maybe we need the macro detail. And another important character is just the multi-dimension dynamic character. For example, maybe all the details change that dynamic so quickly, maybe just based on the time, maybe based on some other different aspects. So now we also gave the definition of the spatial intelligence of the Grotto status. Spatial intelligence of the Grotto status refers to the relevant methods and solutions that use AI to analyze the spatial temporal characteristics of the Grotto status. For example, the geospatial AI of state digital heritage. And we know the spatial intelligence of digital heritage is very, very important to the inherent control, confidence, and something else. And just based on the heritage, we just do some research work for the virtual restoration. What's the virtual restoration? Virtual restoration might be just refers to the restoration of the historic geometry and texture of control heritage based on the higher precision 3-dimensional model 3 computer, and just based on the higher precision model, and we can just get the virtual restoration and to know some place we, for example, just disappear or some just split something else. And the second part maybe is just the most important part of the presentation. We give the method. You know, the intelligence theory and method framework is just as follows. Firstly, maybe just we get the spatial, how to get the spatial data, and then we just based on the spatial data, we did some spatial information extraction, and then we just refine the scene management. Finally, we just do some spatial intelligence service. And first important thing is just construct the conceptual model of the temporal and spatial cognition of the control heritage. For example, we need to make use of the multi-level data of control heritage to study the construction method of higher level knowledge, expression model of overall environment, just the heritage, where the heritage it is. Then the control relics ontology, maybe we know how many hands are there and some details, and the some partitional characteristics. For example, the any hands details. And this is the multi-level data. Maybe this is just an example of higher level knowledge model. And then it's a unit object. And with this just conceptual model, we just can realize the promotion of control heritage expression from data to knowledge. Then we need to development typical knowledge extraction algorithm of control heritage. we did some research on the extraction method of typical geometric features of cultural heritage, such as the spatial distributions, three-dimensional skeleton lines, and the damaged surface of the cultural relics. Actually, in the third part, we will give an example to how to explain how to we do it. So don't worry about if you can't get the point of these slides. And then we maybe need to develop intelligent digital restoration methods of cultural heritage. For example, some restoration method of template matching based on the similar entities. And this method can solve the digital restoration of incomplete of cultural heritage with reference similarity. And then we need to develop some intelligent digital restoration method of cultural heritage. For example, research on the digital restoration method of complete parts based on the higher levels knowledge model. Maybe this is just some theoretical support, and when just we get the skeleton line of the hands, and when just forecasting some middle, and so we get some clue to some digital restoration. We also develop some intelligent knowledge modeling tools for the control heritage fields, and these tools, is very useful for just for some people. Maybe they do not know how to get the knowledge model, something else, and it's very easy to use. And we also developed we also developed a system for the virtual restoration of cultural heritage. And firstly, maybe we just get the conceptual model, and then we just can estimate how serious of the disease something else, and then we just get the digital restoration some parts, and then we can compare the restoration before and after. And the system we develop is very widely used in the digital restoration project of the cultural heritage in China. Now I will give you two specific cases. And first one is, just the virtual restoration of the Dazu Southern Han Buddhitva statue. And this project is very important in China. And we almost focus on this project more than 10 years. When I get my PhD degree, almost 2005, and I just get the opportunity to do it. So from now, we still did some research work based on the data. And in this project, we just get the very millimeter data of the statue before, during, and after restoration. And we also can realize the digitalized restoration of grottos, and also the restoration result help restore the statues. So, and this has because of the complexity of the disease, the difficulty of the protection, the higher technique requirements, the number of displays involved, and the wide range of experts involved, it pioneered the restoration of large-scale immovable cultural relics in China. So this is, have a great impact in China of these projects. Actually, in these projects, we just get the multi-spatial scale three-dimensional information collection of the Dazu Southern Han Buddhitva statue. Actually, for the environment, we just can get the resolution maybe 5 centimeters, and the maybe the southern hand Bhutkadeva statue based just located this area, and this area the resolution can be just 3 millimeters. And some details, actually we use the higher precision 3-dimensional laser scanning of the articular arm, and we can get a very nice resolution, almost just the 0.045 millimeters. For the details, we can get the 3 models of the hand. The name is that Dazo southern hand Bhutkadeva statue. So at the beginning, maybe they are almost 1 southern hand here, but now maybe just we can get some clue of 846 hands are there. And in these projects, we just constructing the space-time information model of the Dazu southern Bhutkadeva statue. We also can intelligent extraction of this in Dazu based on some deep learning. We also can just did some word restoration in Dazu. Just word restoration use the spatial analysis. Although there are almost 1,000 hands are there, and we can find some interesting rules. There is a straight line, and the left path and the right path, they are just symmetry. So we can use the spatial symmetry of culture relics themselves to find the basis for the restoration. For example, if we want to just get some clue how to restore the broken parts are there, for example, is this just the left red parts? So the easiest thing is just to find the symmetrical hands in the right pants, for example, this red pants. So we can get the clue to just restore it. So the spatial analysis is very important to the virtual restoration. For example, especially for some contract relics, they have the similar and symmetry properties. Just the spatial information on the medical level just have the spatial symmetry similarity. That means in these 2 parts, maybe the left part and the right part, left hand and right hand, they maybe have the same shape, the same length, and the same details. That's very important to give some details for us. For example, in this 2 green paths, maybe we can find these two hands, they are similar and symmetry. So maybe they can help each other to work restoration. And this green too, they are the symmetry and similarity paths. They can help each other. And this purple one, they can help each other also. So actually, the similarity and the symmetric is very easy properties. We can find it directly and can use it. But sometimes maybe only the symmetry and similarity is not enough. For example, if we want to restore these broken hands there, how we can know the length and how we can know that's the shape? So maybe in the traditional methods, maybe just use some tools, for example, some sticks, just to get the shape, and then the workers just to restore it according to the shape. From the traditional method, we can find, oh, it's just like a skeleton line. So just based on the 3D model, we can get a skeleton line extraction algorithm, So we just can prediction methods of just amazing types. So just virtual repair, and this is the actual repair, just based on our virtual methods. So we just give almost every hands repair just designer. So it's very useful for the real work. This just the traditional methods. For example, is work here, just based on some sticks. So that's why we've just thinking about the skeleton. Why we just need the skeleton line. So just from the real work. So I also think for the PhD students, if you want to do some research, so maybe the project, some the real work is very, very important, because our research just should from the project, from the real work, and then the result of our research, I think, should help them. So when this happens, you will feel so excited. Oh, what I'm done is very useful. Oh, they can use what I get. What I get can help them. So you will feel some very happy and get the confidence to go on and to find some new method to help them again. So maybe it will be a good circle. We just help each other. Maybe, they need our, maybe some, thematic maps, but maybe we need some confidence from them. Oh, they just say, Dr. Hou, what you did is very useful. Oh, from your map, I get some clue. Oh, how you can help me. So maybe sometimes, so what they said, maybe just the background of our research work. So, I just as before I explained, in the traditional work, it's just maybe just based on some sticks to get the shape. But what we need to do, just need to be based on the 3D cloud, maybe some artificial method. So just based on the 3D model, we can do some automatic skeleton extraction algorithm. So for every one hand, we can get the skeleton, or we can know the length of every finger. I had told you, they are almost still have 846 hands are there. So we can get the length of every finger of every hands are there. So from all the details, we can get some linear relationship between the middle finger and the ringer finger of some hand. So maybe based on the well conserved fingers, we can predict the broken finger length or something else. For example, this finger, maybe we can just get the length of this finger's length, and then we can just get the length and the shapes of the broken hands. So this is the feature extraction of the hand selecting of the solid hand Guanyin Dazu. And just as we said, we just development a tool to just set up the knowledge map of the hand Butera statue. We get the knowledge visualization and some data association and some data depression. And Actually, we also just get the acknowledgement map, construction of knowledge map, and we also can search from the website all kinds of information just about the those on the handbook hit bar, and then we just can construction the knowledge map, automatically. So I think, for some, for example, archaeological or some restoration work, they think it's very useful, can get some clue to restore it. Actually, recently we also did something automatic recognition of the key facial features of Buddha statues through deep learning technique, and it's very useful. For example, we can automatically recognize of the key features of the Buddha face through deep learning technique. It's very interesting. Do you find almost every Buddha, their face shape just like a peach? That's why when we look at the Buddha, we just smile. We feel so peaceful heart, something else. Maybe everyone just so it's very interesting in the peach. So it's a very interesting work. We still did not just produce the paper, so just do some work recently. So actually this Buddha just is located in the Sichuan Chongqing area. It's very interesting. If CC have the opportunity to visit China again, maybe we can just visit this Buddha. It's very how to say it, very beautiful, because almost this is constructed 2000 year before. And it's very interesting. We also did some artificial intelligence, and this maybe some can let the facing image of the Buddha statue come to life. Wow, it can smile to us. Actually, another case is just the reproduction, just based on the 3D cloud point. And firstly, we just can get the higher precision information, and then we just get some knowledge map. And actually, this reproduction model is located in our campus. It's almost 20 meters high. We just reproduction the statue 4 times. The first time just ahead, the second time maybe just 10 meters, and third time just 10 meters also, but a different material. But finally, it's about 20 meters. So it's very interesting. And just based on the cloud, we just can do some data collection and the data management, and we can automatically recognize some map and some characteristics, and it's all automatically. And we can also some knowledge construction of the disease index. We just can get some, we can calculate the index of spawning disease and just estimate how disease is serious and how we can protect, and how we can give some suggestion and something. And we can also just automatically identification of disease index. And this is some reproduction technique workflow. Firstly, just the map, and then just subdivide different convex, and then we just print it, and then we just construct it, and then just rebuild it. It's very interesting. Okay. So maybe actually it's a very big and very, very, large works. Just because of the time, I just introduce it so briefly. This work we did almost 5 years. I just as a talk. This is my campus. I think it's very interesting work. Yeah. And actually, how to say it, 3D cloud point is very, very useful, but how to use this 3D cloud point to other aspects, for example, the civil engineering, for example, the architecture, and so on. Maybe that's the point. So maybe that's what I want to say. Actually, the artificial intelligence based on the 3D cloud point, the most important thing is we just use the cloud point deeply. We need to get some new information from the cloud. We can apply this data or the result to different aspects, to different fields, and let most people to do it and to know it. So finally, I just gave some summary. Actually, only the spatial intelligence recognized by the control relics protection industry maybe is very important. For example, most people maybe hear the research field, maybe just the survey and mapping, geometric or something else. But how to do it? Maybe just we need to the control relics protection industry. That in that area, experts, some research, they can understand our work. So our work maybe is useful. If they cannot understand, if they don't think what we did is useful, why we need to do it? I think that's very important. That means from the beginning of the research work, we needed to discuss with experts from the relics protection, maybe some archaeology, just together, and they think what we did is what they need. Maybe I think it's very useful. And another thing I want to share with you, maybe we need to expand the depth and the breadth of the spatial intelligence and virtual restoration application of the Grotto statue through interdisciplinary integration. So that's what I mean several times. So actually, what I actually in my research team, not only from the survey and mapping, GIS or photogrammetry, not only in my area. Some people, I have 2 PhD students, their major is art, and another one is just from the architecture, another one just from the civil engineering, and even from some special planning, and one from the environment engineering. So I think maybe need some different research field integration, and just can sit here to discuss with each other, and everyone just step forward 1 steps, and they just so how to say it? Maybe what the thing belong to what to do is not the most important thing. The most important thing is who did it. So the field is some people's. And finally, maybe the hybrid intelligence based on the spatial intelligence and the physics intelligence, maybe in the future's works. That means what we are thinking about, and the relics protection experts thinking about just together. So maybe it's useful. Thanks, Jack, and thanks, Cici. It's just what I'm talking today is over today. So thank you so much.
Thank you very much. That was a brilliant presentation, very interesting, and very, as you say, very exciting that you can take such a good workflow across so many different technologies and then have that applied back into reality for a genuine benefit for everyone. Really, that's amazing work. So, yeah, wish you a lot of luck on the progress of these projects. It's very interesting.
Thank you.
Cici, yeah, you came in just a little bit late, but very good presentation, wasn't it?
Yeah, indeed, excellent presentation. Thank you very much, Professor Hou, to accepting our invitation and coming to, showing up. It's very nice to see your face. I haven't seen you for so long time. It looks like
you see, we haven't seen each other.
It looks like century.
Look forward to seeing you again.
Yeah, I hope we can travel again freely and we can come again to you in Beijing. But you also can come here to visit us in Sydney.
I hope so.
We have now at the moment 2 PhD students that are doing something with heritage, and that's why I'm very happy that you agree to show your work. Before they might have some questions, but before we start with the questions, I'm wondering, you have many different projects. I remember this big Buddha that is in the campus in Beijing. And I'm wondering, how do you store the information? Because you have all kind of different objects. You have the meshes from the objects, but you have individual small figures. And do you have some systematic way to store the information and to maintain everything that you have done? To identify objects, and after that to store them in a database management system or whatever, or you just keep the information project by project, object by object, last files, and I don't know. Yeah, so I'm very curious how you maintain all this data from so many different projects.
It's a very good suggestion. You know, our university maybe is maybe in China, maybe it's just the first did this research. So maybe in China, different you know, some companies, some teams to get the information, the data. Some students from the school. So, for example, actually, for the 大族少年汉 Buddha statue, when I just begin to when I come to work in BUCEA 2005, you know, it's a very good opportunity. You know, my classmates. He works for the, you know, the Chinese, just the Chinese relics government. So we just work together. So maybe he has a very big project, including the data. The data acquisition and maybe some environment analysis, and maybe just restore the 大都少年汉 Buddha statue, and some other just did some disease analysis. So maybe 5 different aspects. And for the 3D documentation, how to get it. So just I gave some, you know, the how to get the data and the different, maybe different skill. This one, different skill, maybe use the different you know, the different equipment to get the data. But you know, it's a very big work. So actually, the real work just is finished by the students. My students, he has a team almost 40 people in that team. So in order to get this data, maybe 6 years, 4 people, four people did this work, and just the outdoors work maybe just the 4 years, and indoors work maybe 2 years. So it's a very you know, big work to get the information, not only by our university. Maybe our university just did some instruction for them, and so we have the opportunity. We have the opportunity to do some research work based on this data. So you know, we have the three stages data. Before the restoration, we get the data, and you know, in the middle of the restoration, we get the data, and after restoration, we get the data. So I think it's almost possible now. So I think it's very important for us to have the research data. So
and when you reconstruct these different artifacts, their hands or whatever, do you try to classify them somehow, to attach some attributes to them, to be able to document them and to search between the different hands objects?
I think a very good question, Cici. And so actually, you know, when we did this project, you know, the government maybe need us to finish the work 5 years or 3 years. So at that time, we just get the data and get a 3D model, maybe just some virtual restoration, just based on hand, based on model, not automatically, no AI. So recently, so you know, the project is done, but based on this data, we did some work. For example, the classification, and just get the skeleton and something else based on AI. At that time, we just did it by the hand, based on 3D, but now just based on AI. So just at the beginning.
Okay, yeah. It's really very impressive work. I know that you are working for years on reconstruction, even in very small details, and you must have a lot of experience by now. Okay, so probably I'll stop talking for the moment, and I ask our students to ask questions. Who wants to ask a question? Ibrahim? Yes. We are in a lab here, speaking with several people. So I will mute myself, and you can go, Ibrahim.
Actually, one of the questions is already asked by Dr. Cici in how to store these kind of huge level of data, but actually the presentation was very fantastic, Dr. And cover all the aspects. That's maybe actually
probably I can continue because mute yourself, not to make icon. Actually, Ibrahim is working on, it's going to work. He started very recently. He's going to work on, creating an information system for bridges, stone bridges. And we are in contact with a company which maintains the stones in yeah, you know, old stone bridges. And for them it was very interesting to be able to detect which stones need to be replaced. So to identify individual stones within the bridge and to be able to figure out whether the stone is damaged. And yeah, after that, cut a new one and just replace the old one. But the problem is, okay, so they have a very good, very high accuracy cutting machines for the new stones, and they want to have accuracy about 1 millimeter. So they have to, they're interested to have a procedure to identify from a mesh where the stone is. You know, when you have a stone and you have a small holes where exactly the shape of the stone is with 1 millimeter accuracy. So having so much experience with all kind of these small details, do you think that this is possible to achieve such an accuracy with laser scanning? And what kind of laser scanning you have to go with? Something with really kind of 1 millimeter accuracy, or even something lower? What is your opinion about it?
I think it's very interesting work. Actually, last year I have one postgraduate just maybe did some similar work, just because it's not a PhD, just postgraduate, maybe just 3 years. So actually, I don't know what's the background of the PhD student, the background.
Geomatics.
Or geomatics. Maybe I think if it's possible, you know, if you can find a civil engineering students or the teacher to discuss, you know, for example, if you want to estimate the status of the stone bridges, so you need to know what's the main parts of the stone stages. Maybe the arch shaper, and maybe just some, you know, some key apart something else. That's the points you need to automatically get from the 3D point cloud. So yeah. So if it's possible, maybe sometimes we can discuss it. So at that work, we just get the from the 3D cloud point, 3D point cloud, we can automatically get the skeleton of the shape of the stone bridge, and from
but it's not even the general shape, but individual stones, you know.
Yeah. So maybe just split. So I think maybe that ideas from the civil engineering, not only from the geoinformatics, because we know the data, but we don't know what we need to get from the data. What we need to get upon maybe is the most important, the base of the research work.
Yeah. Okay, thanks. And there is a question from Rehan. Go ahead.
Yeah. Hello, Professor. I like your research, and you mentioned that there is students from architectural background in your group, and I want to ask how architectural students can contribute to the project in the 3D modeling or laser scanner. Yes, and Pointcloud. That's my question. Thank you.
I'm right. You are from the architecture. I'm right, maybe.
Yeah. I'm architecture student. I'm from Chongqing University. During my
great.
master.
Great. Actually, you know, actually the 3D cloud point maybe is very important to just did some research for the architecture structure, and for example, the minting style, relics. For the first important thing, I think is the classification. You know, maybe you need to classify the 3D cloud point to get the maybe 7 or more class. And for example, so excuse me, I forgot how to say it. the 柱梁, you know, that's very important.
Yeah.
The traditional Chinese architecture. So, and then for the every part, you need to the detail. For example, the dogong, maybe you need to divide it and classify it again. So, I think it's a very, very interesting and interesting research field, and the result is very, I think, maybe can produce a lot of new ideas. So, in our research team, they say maybe have 2 PhD students. They just get the Mingqing architecture, for example, the Forbidden City and something else in Beijing. So maybe a little similar. So maybe the classification something that's something else. So
I see. Thank you.
We have also another PhD student who is also working in heritage. Shufia, would you like to ask something about? Somehow Shufia is idle. Okay, anyhow, but she can watch the presentation and she can, yeah. I think thank you very much again for being with us. Some more questions? And okay, if there's no questions, so thank you very much for being with us. And we have to keep in touch because, yeah, I know that you have a lot of experience, and now know that your group is really leading in China with respect to restoration and reconstruction of heritage artifacts. So it's going to be very useful to keep in touch and to be able to discuss. So we may have another more specialized session where we can discuss specific topics and you can ask questions, and we can organize probably some kind of presentation with your students and our students to exchange information. Yeah.
Okay, and thanks for inviting, and it's my pleasure, and I think it's very useful to discuss with each other. So maybe next time we can organize before, maybe for example for the bridge or for the architecture, maybe just the different topics we can have the students together. You know, nowadays maybe the students, their English is better than me, so I think they can maybe discuss and talk freely. So I think it's very useful. Thanks a lot. The wish we can discuss just later. And so maybe internet is a very good, good ways to communicate with each other and to discuss and to share what we did together. Thank you.
Very good. Thank you very much, Professor. That was an excellent presentation. We'll look forward to meeting again. Yes.
Thank you, Jack. Thank you, see. Okay, bye-bye. Thank you.
Bye-bye.